Welcome to the Center of Excellence Lab Schneider Electric. So today we are going to see the Advanced Industrial Automation and Building Automation Lab. So in this lab we are going to see the fire alarm system. So what is meant by fire alarm system? So fire alarm system warns people when smoke, fire or carbon monoxide or other fire related emergencies are detected. These alarms may be activated automatically from various sensors such as smoke detectors, heat detectors, or multi-detectors, or sometimes it may be activated by manual activation devices such as manual call points or pull stations. So how the fire alarm system in a home will work. So this is an arrangement. You can see the fire alarm system over here. If in case of any fire and smoke, so it will be detected by the sensor which is installed on the top, and it will produce a beep sound. So it gives an alert message to us so that we can easily do an precautionary action. So what are the types of fire alarm system? So fire alarm system are generally classified as addressable fire alarm system and conventional fire alarm system. Addressable fire alarm system different from conventional fire alarm system in number of ways. So it adds more flexibility, intelligent speed of fire identification, and precise location of the fire spot, and scope of control, and additionally ease of installation and modification of existing systems. A conventional fire alarm system employs one or more circuits connected to initiating devices wired in parallel. These sensors are devised to dramatically decrease the circuit resistance when the environmental influence on any sensor exceeds a predetermined value. In addressable fire alarm panel, so the address of detector or a sensor or call points or a sounder have been provided. So they are formed in a loop. So each device has a unique address. The system may contain one or more loops depending upon the size of the system requirement. So this is the basic difference between the conventional fire alarm system and addressable fire alarm system. So we will see the introduction part.
So this is the experiment called as fire alarm system or addressable fire alarm system. So now you can see the board of it. Okay, this is the work table of the addressable fire alarm system. Here you can see different rooms. Okay, for example, here you can see a pantry. Here you can see the canteen. Here you can see the electrical room, and here this is the conference room, and this is the entrance point. You can see that here you can see one more conference room. Okay, this is the director room. So this is the layout of an office. In that we are going to locate the different type of sensor. For example, in the pantry we are going to keep a heat detector. So this is the input device. It's the input device which senses the heat. Okay, if it reaches the prescribed temperature, so it will work. So next one is the multi-sensor detector. The speciality of the multi-sensor detector is it can sense heat as well as smoke as well as fire. So three things can be sensed in this multi-sensor. And one more multi-sensor, it is here. So here also we have kept that. Here it is the AHU. This is the air handling unit. I think in the theory we might have learned about the air handling unit. So it is nothing but a HVAC, heating, ventilating and air conditioning systems control AHU unit. And here this is the one more conference room. Here you can see a smoke detector. So this is meant for detecting only the smoke. And once again, here also we can keep a smoke detector, but it's not necessary. We are doing an experiment, that is fine. So this is the input device. So this is also input device, which is known as MCP. It is placed in the entry point. Here you can see the entry point. MCP is nothing but the manual call point. Okay, it should be operated manually in spite of any fire. So these devices will work automatically, but this has to be activated by a person. If he sees any fire or smoke or anything, he has to press this button. Okay, so this is the MCP and this is the output device. So the previous devices what we have seen are the input devices. Okay, so this is the output devices. This is a sounder, so it produces both light and alarm, so for making the people cautious. Okay, so this is the experiment called as fire alarm system or addressable fire alarm system. So now you can see the board of it. Okay, this is the work table of the addressable fire alarm system. Here you can see different rooms. Okay, for example, here you can see a pantry. Here you can see the canteen. Here you can see the electrical room, and here this is the conference room, and this is the so this is the fire alarm panel. Here you can see. So here only we can able to control all, but here we can see that every devices are managed here. All the input devices should be managed here, so that we can.
In this video, we can edit notes.
So this is the fire alarm panel. So in this, we are going to manage all the input devices as well as the output devices. So here you can see the power supply, and there is a battery backup also will be there. So here you want to switch it on, and we can see all the parameters to be managed. And in this screen, you can see the location where the fire or smoke or what type of fault has been happened will be detected in the screen. So we can easily identify the spot. Okay, so this is the purpose of the fire alarm panel. Once this hooter or maybe the sounder is switched on, there is one more accessory. We can add this control IO modules. So this is meant for exciting the sprinklers. I think in many movies you might have seen the sprinklers in big buildings. Okay, so here we can control the sprinklers, and also you can control the fire extinguisher also you can add here. So that this is the output control devices. But as a demo experiment or what we are going to work in a simple panel, so we have not included this, but it can be extended with the exhaust fan. For example, any poisonous gas leakage is there, it may be detected from this smoke sensor. In the smoke sensor it may be detected, and immediately if it is connected to a exhaust fan, it immediately excites, and it will be exhausted outside. And similarly, if any dangerous fire is there in case of in pantry, the heat detector will detect, and immediately if we connect it to the sprinkler system, the sprinkler will switch on, and immediately it will extinguish the fire. So this is about the fire alarm system. Now we are going to see how to program it and how to take the output.
Yeah, so for this purpose, we are going to use a software. In this application, we are going to use a software which is known as FXNet configuration tool. So it is a product of WinFX3Net software programming, so which enables to configure all the input and output devices and used to transfer the program. So this can be enabled to configure up to 32 panels of the FX family. So by application of the number of loops. So we will see the hardware configuration. The hardware configuration was detailed in the video itself. So here this is the bench of a fire alarm system. So it is an addressable fire alarm system. So as we told already, we have a heat detector, we have a sounder, MCP manual call point. Here it is a smoke detector and response indicator and multi-sensor detector. 6 and 7 will be the multi-sensor detector, and number 8 is a IO module, which will be explained in the upcoming slides, and next will be the fire alarm panel. So first we'll see the wiring diagram. So how it is wired. So this is the FX panel. So the fire alarm panel will be placed. In that, all addressable detectors and fire alarm devices and call points are connected in a loop. So maybe loop 1, loop 2 maybe. So it can be connected in many loops. So here you can see, so where a sub loop is formed along with that, and we do have the output devices can be extended, input devices can be extended. So like that, it can support up to 32 panel devices in a single panel. So that is the beauty of this fire alarm panel. So this shows the wiring diagram. So it forms a closer loop. And the next, so this is the actually not a wiring diagram, it is a block diagram. So here you can see the number of input devices forming one loop and number of output devices forming other loop. So two loop controller we are using here. So it can be extended to many loops also. There is a possibility of the same. And we can see individual devices one by one. So first we are going to see the heat detector. The heat detector is designed to detect the heat of a smoke. So it is situated in the kitchen top or wherever it is required. So here it will not produce the false alarms, so that we have to keep that in a particular spot. So here we do have a thermistor. So these type of heat detectors work on the principle of rate of rise of temperature. So if the temperature is fixed for 45 degrees, if the prescribed temperature is reached, rate of rise of temperature will be increased. So this thermistor will act and it will try to activate the output devices. So this is the model. So EDI 50 we are going to use in our panel. The second type of detector is a smoke detector. We know already the smoke detector operates in two principles. One is the optical principle, other one is the ionization principle. The device what we use in our lab is the smoke detector, which is operating in the principle of optical detection. So optical detection, I think we might have already studied. There will be infrared LED and we have a photodiode. Under normal working condition, there is no reflected light to the photodiode and no output will be produced. But when the smoke enter into it, so what will happen? The light will scatter and try to reflect the light to the photodiode. Once the photodiode receives the signal, it activates the system. So it is basically the light scattering principle. One more principle we know, ionization principle. The ions in the smoke try to interact with the cathode and anode and it will produce an output, that is the ionization principle. So this device is EDI 20 optical type smoke detector, which we are using in our application. The third one is the multi-sensor detector. The multi-sensor detector is a special type of detector which utilizes the photoelectric and thermal sensing technology. So it detects the smoke, heat and poisonous gases also. So it is the signals from the photoelectric sensing element and temperature sensor are completely independent. So it will not conflict each other and represent the smoke level and air temperature respectively in the vicinity of the detector. So for this we use a multi-sensor detector of EDI 30. The next type of a device is the response indicator. So this is the first activating device. While doing this experiment also we can have a notice of the same. So response indicator are connected to automatic fire detectors in order to indicate quickly the source of fire alarm from detectors which not easily accessible or visible. So this is the fast response detector, like reflex action in the human body. Once the fire is noticed, immediately it will try to sense. The response indicator have two LEDs respectively. When the fire alarm system is connected to the panel, and if any fire has been noticed, immediately the response indicator will try to activate. Only one external response indicator may be connected to each detector. So I think in many malls we may see only one response indicator will be there for all the floors. Next one will be the addressable IO module. So as we told already, IO module is fully responsible for interfacing the external output devices. So it can be connected to the normally open dry contact, so which gives the changeover relay of an ancillary equipment where we can connect a sprinkler system or fire extinguishing system. So it is available in different models. So according to our requirement, we can install any one for the operation of the extinguishing systems. The next one we are going to see is the sounder. A sounder is an electronic device which makes high pitch sound to make alert of the people in the building. The sounder can be programmed to sound in different tones also. It can be in certain low frequency or high frequency or medium frequency. So according to our application, we can program the sounder. Apart from the sound, we receive a strobe light also here. So the blinking of the light can be observed in this sounder. So the final one is the manual call point. The manual call point is manually operated switch. If a person in a passage or in underground or in somewhere else, if he notices a fire, immediately he can press this switch so that the fire alarm system may be activated. It is manually operated, so it is known as the manual call point, MCP. In case of emergency, he can operate it and he can try to alert the people, or he can make initiating of a fire extinguishing system. Finally, we are going to see about the panel, FXM panel. So this is the brain of the system. So this system has many controls incorporated inside. So this receives the information from all the input devices, which monitors all the input devices and produces the output. It is it is a device which has an operational integrity and provides automatic control of equipment. The transmission of the equipment is done by the loops. So by operating by the two loops, it can function perfectly. And also it is used to make the system be in alert mode. So it is provided with the primary backup and the secondary backup, because the primary backup is the electrical power supply which we are receiving from the electricity board, and the secondary backup, we have a built-in battery in this circuit so that it will act in spite of the absence of the actual AC power. So now we can see the application 1. So the application 1 is configure a fire alarm system with MCP and sounder. So we are going to add two systems in this. So we are going to draw a diagram for this, and we are going to do the configuration by using the below table. So we are going to configure the manual call point MCP and the sounder. So which we are going to add in the loop 1. The manual call point is going to be added in the loop 1 and the sounder is going to be added in the loop 2. It has a particular address of 4 and 1, and the type what we are using in our laboratory is XP95. This has to be configured while doing it and bacon discovery. So this is the address of both. So we want to configure in this particular address, and it has to be programmed and uploaded to the panel, and the panel is started, and we have to produce an artificial fault. MCB has to be clicked and we want to observe what is happening. So this is the first application. So these two devices we are going to configure in the first application. How we can program it? So we'll see the programming procedure. First step is panel external settings. First we want to do the panel external settings. So for that, click on the icon FXNet. So this is the configuration tool. Once that is clicked, we want to create a new file. So go to the taskbar and then go to file and click new. Once it is clicked, we can go for the second step, that is panel external settings, which is the continuation of the first step. So here we are going to check certain options. First, we are going to select the standalone option, and we want to choose the panel ID as 0. And the panel type, as we discussed already, it is the FXM panel, and we can give an address or name as NHCE, and we can give add and we can give OK. So this is the first step of the panel settings. Next, the second step, so we should add a panel name. So we have already added the FXM, so it can be added with the NHCE. So it will be reflecting as FXM NHCE. This will be the panel name. Now we are going to click on the loop controller. So once we click the loop controller, there will be various type of ALCB interlock controllers. So we are operating on two loops. So we want to select this drop down list for the controller. So loop controller 1 we are going to do it, and we have number of first loop and last loop we are giving the names, and total number of loops is 2. So two loops we are going to select here, and we are going to name it as loop 1 and loop 2. So the loop 3 cannot be configured, and we are going to give OK. Once that is done, we can go for the loop controllers. So as we have already created the loop 1 and loop 2, so it will be displayed here. So in each loop we have to configure the device as per the application requirement. So our application requirement is loop 1. The loop 1 we are going to click and we are going to configure. Here we are going to configure as per the application requirements. In the loop 1, as we discussed already, we are going to configure the MCP and what is the type of design and what is the type of address and what is the make that we are going to select, and we are going to give OK. In the loop 2, we are going to select the sounder, Bacon sounder. So it is a discovery company, and we can edit the audio or we can edit the frequency here, whichever the frequency is required, that is the mode, we can edit it and we can give OK. So once this is done, the application is ready to transfer. Now the fourth step, we are going to transfer it. So once you click OK, after the configuration, we will go for the tools menu and we have to give an option which is known as send to panel. So now we have programmed the device for sending the program to the panel. So first we want to make the, if you click this send panel, we can see the dialog box of the next one, that is prepare panel. So in the FX net, we have to check this prepare panel. For after preparation of the panel, if you click OK, the panel will start try to start the data transformation. While doing that, we want to check for the what mode of transport. So here also Ethernet port is available and USB port is available. So we will be always preferring the USB serial port in this application. So previously we were using the Ethernet port for communication, but for this particular application, we'll be choosing the USB communication. And if we give OK, the data will start to transfer. Okay, once it starts to transfer, you can see TXD and RXD will be activated. So here we will be sending the data 1, data 2, or item 1, item 2, like that. You can see the displays over here. And simultaneously in the FXM panel, there will be LCD display, and the LCD display displays that configuration had been started and now it is ready for configuration. Okay, so once all the data have been transferred, then you can check for the restart panel. So here one option is there, restart panel. Once the panel is restarted, automatically later in the LCD we can see the FX panel will be displayed like this. So if this screen is displaying, the fire alarm panel is ready. So we are now going to create an artificial fault by pressing the manual call point, and we are going to notice what is happening at the output end. So for that purpose, we will watch the procedure for output.
So the fire alarm system we might have already programmed in my computer, and I am going to transfer through USB. In the configuration we might have seen, we have to transfer through the USB program. So I have transferred the program in the USB cable, so it is going to be connected with the FAS panel. So fire alarm system panel, it has been connected. You can see now the fault is not yet created, so it is working in the active condition. Okay, so you can see all the devices intact. So this is actually multi-sensor. Since now we have transferred the program, it is not active now. So how to identify it is active? So once it is active, here you can see the LEDs will be starts blinking. So once the blinking is happening, you can come to a conclusion that the devices are active. So in the first application, what I have to do is I have to press this manual call point. So I have to check with the hooter is working and sounder is working. So okay, so the first application I'm going to press this so that the fault will be created manually. So now the device is almost ready. So the device is almost ready. So here just now we might have seen the blinking. So once again it takes some 2 seconds time to start. So now I am going to create this fault. Now the device are ready. Here you can see the blinking of the devices. So all sensors is being ready. Okay, now I press this manual call point. Here you can see the fault is being created. Once the fault is created, the alarm is being alarming, and here you can see the location. So there is a fire in zone 1, that is in the conference room. The conference room, you can see there is a fire. So the person who is responsible can make the system activated and he can extinguish the fire. Okay, so this is about the first application. So
Thank you for watching.